Hi, Mr. Rod W here. I'm going to explain why I've traded all my Linux CNC machines in for a 3D printer and share a few things about what I've learned about making 3D printed threads and other engineering mechanisms since I made this move. I've been working with Linux CNC for close to 10 years and I built my spaceship plasma table from scratch and used it for a few years before selling it a while ago. It's well described in this channel. I had a lot to do with the Linux CNC plasma configuration, which is now part of the standard Linux CNC install. I also retrofitted a manual milling machine to use closed-loop EtherCAT drives. And I've helped the developers out by creating the installation images for the currently released Linux CNC version 2.94. Now I'm brand new to 3D printing, but I've been sent enough replacement parts by Anycubic support to fix my stuff up, so I think I'm experienced beyond my years. Honestly, all these things that I broke was really because of my fault, not understanding the technology and the machine that I had. So for years, I was sure I knew which was better for me. I looked at 3D printers years ago and wasn't really impressed, but times and technology have changed. Using Linux CNC, I found building the machine was always fun, but after I got the mill going, I found I never really enjoyed the 3D CNC process. So I didn't mind the CAD process, the design process, but the CAM side, getting it into toolpaths, was much more complex than 2D profile cutting, which I use for plasma cutting, and I kept breaking cutters. The last CNC part I made, I spent a day making a jig, and I made about 50 parts and then ended up outsourcing it to my friend Rishit in India, who sent me 1,000 parts for $1,000 US, landed in Australia, and that was anodized aluminium. So after that, there was nothing left for my mill to do. This is how it came about. I was welding up a batch of parts. I'm not the best welder and things weren't going right. I'd cut down an 8-metre length of 50mm square section into 55mm pieces, and I had a bunch of laser cut plates to weld up to each one of those parts. All I had to do was jig them up and weld them together. All 140 of them. It was hot and I was sweating like a pig. I'd forgotten to take off my daily glasses and put on my reading glasses I use for welding. The helmet was fogging up and I could barely see. As my delirious mind wandered, I began to think about how I could eliminate this production process from my workshop. And then I had this great idea. What if I could get the part injection molded? Within moments, I had it designed in my head and couldn't wait to finish my welding and fire up Onshape to design it. I emailed the model to my friend Rishit to see if he could make this part for me. Sure enough, he came back with a price per unit that was less than the cost I was paying for the powder coating, even if we included the cost of the mold. So it was a no-brainer, but I was a little bit worried about what material to use. I had this feeling that the people that I was getting quotes from just weren't with what was needed for automotive applications. So I was still not sure whether I should do that, and I decided to get a sample part printed in 3D, a 3D printed part from a random business I found on Google called CAD 3D with a capital K. All up, this cost me a little over $80 for the part landed, but once it arrived a week later, I thought it was well worth it. I was actually quite gobsmacked with the amazing quality of my 3D printed sample, and I showed it to a local tool maker and I asked him to quote on making the mold. While he quoted a comparable unit price, the machining cost for the mold was about $12,000, which was way out of the question for my available budget. So as it turned out, I sold the business before I ordered these parts. So then I sold my milling machine and bought a 3D printer, an Anycubic Cobra S1. I figured I could still design and make parts, but I wouldn't have to worry about tool paths and just leave it to the slicer. So let's sort of just talking about functional parts. One of the things I've wanted for a while was a bracket here to hold a phone on a tripod. You can see I've got a little tripod here, and the phone can just slide in here and tighten up, and then we can put it on a tripod and take much better video than what I've ever done by holding a phone by hand before. So that was the first thing I did, and I followed an example that used an arbitrary thread. So this is not a metric thread, what it is and it isn't, but I followed this, and then the nut was made wrapped around the thread, which worked really well. So so that was the first thing, and the base of it here, I hope you can see, is the base of it here is a quarter 20 T-nut. T-nuts, if you don't know them, are used in woodwork, and that I'm really excited. I haven't used it yet, but I'm really excited after a couple of prototypes that I've got it nutted out pretty well. So what I did find is that you've got to think about your slicer settings, because it's very easy to snap a bolt when you tighten up a thread. The T-nuts I heated up to push into the plastic, and I don't think I should have used a map torch, because it discolored the nickel plating quite significantly, and it actually melted a lot more than what I really wanted to make a neat finish. So as I pushed it into the material, so I moved on to some other parts then, and I think next time for that one I'll use a heat gun, which will probably be much gentler. So last week I visited a client in Sydney, and their engineer was printing parts with an M12 by 1.5 pitch thread, and he was using his Bamboo Labs printers. So I came home with a challenge. I decided to print an M12 by 1.75 thread, and it took me a little while to work out the thread dimensions from a couple of the wiki sites and the drawings there, and my Cobra proved to be up to the task. So that I was pretty happy with that. So it, as expected, when I did it on a 12mm extrusion on the printer, it was fairly tight, but I could tighten it up with a spanner. But when I reduced it to 11.8 millimeters, so when I reduced it by 0.2, which is the standard dimension you'll find on a metric thread, it came up really good, and you can see here that it tightens up well into a nut. Now I did then try and make a plastic nut, but I wasn't successful with that, so I've got to go back to the drawing board and see what I can do about that one. Then I tried printing some M6 bolts, which were a little bit smaller. So an M6 bolt has a 1mm pitch thread, and they work quite all right. Once again, I did them on 0.2mm thin. The 6mm one, I didn't even attempt. I just couldn't get a nut started. So to print a nut and bolt pair, I would say that what is easier is to take the approach I did here and just do something arbitrary and make them print together and keep them fairly coarse. So, but if you've got to print these, you only need to print them if you're trying to screw them into something. So, and then another thing that I was intrigued with was some of these people printing multi-part print-in-place models, so there was more than one part printed at the same time. So I tried that with I thought, well, there's nothing more challenging for that than a ball joint. So this one here, I've actually got a ball joint in here, and it's captive, and it was quite loose. Actually, I was quite amazed when I broke it apart and it started moving around as loosely as it is. So I'm thinking that I'd probably try it with a little bit less clearance next time, because it was just, I just had a total guess at it. So now all I've got to do is work out what to make with this technique. So there you have it, guys. There's some of my notes, why I moved to a 3D printer from Linux CNC and got rid of my do-it-yourself CNC machines, and some of my early learnings from an engineering perspective. Tell me in the comments below your thoughts about CNC or 3D printing. What is better for you? I've still got a lot more to share about my 3D printing experiences, but I think this one's long enough for now. So be sure to review some of my popular earlier videos about plasma cutters with Linux CNC, and follow the links in the comments below.